Alright, here we have another 3D vector question. This is question 8 from exercise 12C, pages 347 or 348, or depending on the edition of the book that you have. So, the diagram shows a cuboid whose vertices are O, A, B, C, D, E, F, G, in whatever order they give it to you. A, B, and C are position vectors of vertices A, B, and C respectively. Now what's different about this one is that they use ratios. The point M lies on OE such that OM to ME is 3 to 1. Now ratios usually confuse people, but essentially what this is equivalent to is saying that OM is equal to 3 out of the total 4, so 3/4 of OE. So we have OE and OM is 3/4 of the way along it. The straight line AP passes through point M, and given that AM to MP is 3 to 1, again, we can just write it like that. Prove that P lies on the line EF and find the ratio FP to P. Now what is different about this question is that instead of actually trying to find a ratio, they actually give it to you to start with, and they're saying, given that this is the ratio, show that if this is the case, then P has to be on this line. So what is annoying about this is that I can't use the fact that P is on that line, so P could be somewhere up there, could be somewhere down there, and I just have to essentially use the maths to say that if this is the case, then P, E, and F have to be collinear. Now we have to remember what that means. What I'm trying to find is P, E, and F are collinear, but I cannot actually use this. This is what I'm trying to prove. And the way to prove this is in the same way as proving that something is parallel. I essentially want to write FP is equal to some multiple of FE, which means they're parallel, but because they have a point in common, they have to be on the same line. So this is the starting point. This is the way the book does it in any way. I did it a slightly different way, and I might get into that a little bit later, but I think this one is a little bit nicer because we don't actually have to resort to simultaneous equations. So the thing is, I need to do this all using the information they've given us and the vectors A, B, and C. So first of all, I'm going to have to express FP in terms of vectors. FE is just going to be A, and we'll get around to that. So I need to somehow come back around through the stuff that I know. I know that AM to MP is 3 to 1, so I'm going to want to come back up this way. I don't know what's going on here in this bit here, but I know how that one is behaving. So we're going to write that FP is equal to FB plus BO plus OA plus OP. Now I don't know if that lies on the line yet or not, but what I do know is something about M, that midpoint, and I also can express that using other things over here. So what I'm actually going to write is that is what I'm going to use is the fact that OP, if I use this value there, if sorry, not OP, I did it again, there we go, AP, apologies. If I use this thing here, essentially what I'm told is that AP, so AM is 3/4 of AP, which means that AP is going to actually be 4/3 of AM. So if I write that here, that is FB. I may as well substitute this right away. That's minus C, that is minus B, and that is plus A plus 4/3 of AM. Now, this doesn't help right away, but using this, I can actually express AM in terms of vectors A, B, and C. So what I'm looking for, just off the bat, it's always good to keep in mind what we're looking for. I'm looking for this. So FE is going to be vector A, so I'm going to actually try to look for K times A. So with any luck, that and that will cancel out, and all I'll be left with is a multiple of A. So in the meantime, I'm going to come over here and I'm going to figure out how to express AM. So A to M, except I want to go via this one, which I already know. So AM is equal to AO plus OM. And again, we've already said this, OM is equal to 3/4 of OE. So that is AO plus 3/4 of OE. And these are all already just ABCs waiting to be used, so that is minus A plus sorry, I have not actually done OE yet. OE in itself is going to be so if I were to go from O to E, we're going to go across, up, and back. That is equal to A plus C plus B, which means that this is actually minus A plus 3/4 of OE, which is this, A plus B plus C, giving us, if I do this all together, take away A, that's going to be minus 1/4 of A plus 3/4 B plus 3/4 C. So I now have, I had to go via a couple of different steps. I had to go AM, break AM down, which gave me OE, and then I had to break OE down. But in the end, I can now substitute all of this back into there, and we have our minus C minus B plus A plus 4/3 of all of this minus 1/4 A plus 3/4 B plus 3/4 C. And it turns out that actually, this 4/3 is going to cancel out these 2 3/4. We end up with minus C minus B plus A plus, that is going to give me minus 1/3 A. That is going to give me plus B. That's going to give me plus C. And this is exactly what I was looking for. That C is going to cancel out with minus C, that B is going to cancel out with minus B. And what we are left with is 2/3 of A, which I can write as 2/3 of FE. So because FP is equal to 2/3 of FE, FP and E are collinear, which means that P lies on EF. And on top of it, because I know this, that means that P is 2/3 of the way along FE, which means that the ratio FP to PE, if FP is equal to 2/3 of the whole thing, then that is going to be equal to 2 to 1. So in total I have 3 parts. There we go. So that is the way that the book told us to do it. Now, another way of doing it, which I may not actually go into much detail here, is the way that I did it, because I'm so used to doing stuff with ratios, where essentially I'm looking for the ratio. What I did is I pretended that they hadn't told us this, and I created a new point X or something, and I pretended that that was X. And essentially, I said, I don't know how far along XM is, so I said that AM was equal to lambda AX, and that FX, now that I know it's on the line, was equal to mu of FE. And then I redid the same thing as we've done with other exercises, where I essentially expressed everything in terms of A, B, and C, and I solved the simultaneous equations for lambda and mu, and I found in the end that if that is already on the line, then the ratio has to be that. And therefore, essentially I proved that X and P were exactly the same point. If you're interested, I can maybe show you that proof at some point. But this one's a little bit nicer because it's kind of just, you have to go a couple of layers deep. But we don't actually have to solve any unknowns or make any unknowns up. So there you go. Enjoy.